Today, we are diving into a huge, hidden problem in the world of scientific research. It's like a ghost in the machine that's costing us billions and honestly just slowing down progress. We're going to talk about why we keep paying for the same failures over and over again. Okay, let's just jump right in. Look at this number, $28 billion. That's the estimated amount of money that gets wasted every single year in the United States alone on research that, believe it or not, has already been done. It's kind of mind-blowing. And this isn't just about the money. All that waste, it's a massive drag on innovation. It slows down the discoveries that could change our lives, curing diseases, creating new tech. We're literally paying to reinvent the flat tire. So, yeah, that brings us to the big question for this whole explainer. Why? Why are we stuck in this loop, just paying for the same mistakes again and again? Well, the answer reveals this hidden issue that's plaguing the entire $2.5 trillion global R&D industry. All right, section 1. To really get a handle on this ghost, we need to pull back the curtain on something called dark data. This is the invisible force that's driving all this waste. So, what even is dark data? Well, imagine a scientist runs an experiment. They're hoping for a breakthrough, right? That their new drug works. But it doesn't. The experiment fails. Instead of sharing that result, it's often seen as, well, a failure. So the data just gets tossed in a metaphorical file drawer, never to see the light of day. And the scale of this problem it's just staggering. The source materials suggest that about half, 50%, of all preclinical research just becomes dark data. That's half the work, half the money, half of everything we could have learned, just poof, gone, completely invisible to everyone else in science. Okay, so this leads us into what's known as the file drawer problem. It's this really vicious cycle. And there's a perfect example that shows exactly how it works. It involves a really common antidepressant and some zebrafish. And this right here, this just perfectly illustrates the whole mess. Check out this cycle. You've got Lab A. They test Prozac on zebrafish, and nothing obvious happens. They think, well, that's boring, and they file the null result away. A couple of years go by, Lab B sees nobody's published on this and gets a grant to test the exact same thing. They run the same experiment, get the same failed result, and you guessed it, that data also disappears. It's just a loop of wasted time and money. But here's the real kicker. It's not just about the wasted cash. It's about the lost opportunities. Because nobody shared that boring data, it actually slowed down a much more important discovery. Turns out Prozac does have an effect, but it's transgenerational. It lowers stress hormones in the babies of the fish that were exposed. That's a huge finding, and it was delayed all because failure was hidden away. So how in the world do we break this cycle? Well, what if we just flip the whole system on its head? What if we actually financially rewarded scientists for publishing their data, especially their failures? This is the huge shift the source material is talking about. We go from the old way, which is all based on trust, where a funder just hands over a check and hopes for the best, to a new way based on verification. In this model, the funder locks the money in a digital escrow, and those funds only get released once the researcher uploads their verified data. It doesn't matter if it's positive or negative. You get paid for the work, not the outcome. So how does this new way actually work? Well, this system uses a really clever bit of tech that basically acts like a digital vending machine for research money. You prove you did the work, the machine spits out the cash. Simple as that. The secret sauce here is something called a smart contract. It's basically a self-executing agreement. Here's the play-by-play. A funder, maybe someone like the Gates Foundation, puts $500,000 into the contract. That contract is programmed with one simple rule: release the money when and only when verified data is uploaded. The researcher does their thing, uploads the full data set, and then this independent system called an oracle checks it for integrity. Once it gets the green light, boom, the contract automatically pays the researcher. And this is the most important part. The smart contract doesn't have an ego. It doesn't care about getting splashy headlines or big breakthroughs. It has one job: make sure the work was done and the data is real. This completely kills the incentive to hide failure. In fact, it does the opposite. It gives you a direct financial reason to publish it right away. Okay, so we've now unlocked all this data that used to be hidden, all this failure data. What happens to it? Well, this is where it gets really, really cool. It stops being waste and becomes an incredibly valuable new asset. This quote from the source docs just nails it. Think about it. If you're a big pharmaceutical company, what would you rather do? Spend $10 million testing a new molecule from scratch, or pay 50 grand to see that another lab already proved it was a dead end 3 years ago? It's a no-brainer. And you can see the whole business model right here. D-Reticular, the company championing this idea, is projecting a massive shift. Year 1, they make money from grants to get this platform going. But look at year 3. The business is almost entirely driven by licensing these super valuable failure data sets. That's high-margin, recurring revenue. And the market for this stuff is huge. It's not just big pharma. AI developers are starving for this kind of data to build smarter models. Energy companies can skip testing bad battery chemistries. Ag tech firms can learn which crop treatments don't work. I mean, any industry that relies on R&D can benefit from knowing what not to do. So by fixing this basic data problem, we're not just saving a bunch of money or making R&D a little more efficient. The goal here is actually way bigger. It's about fundamentally changing how science works, for the better. What this ultimately creates is a permanent public library of every scientific attempt, the good, the bad, and the null. A failure in a lab in one country instantly becomes a lesson for every other lab on the entire planet. Failure stops being something to be ashamed of and becomes a public good that pushes everyone forward faster. And that kind of leaves us with one final big thought. If we can find so much value in what we used to consider worthless, failed experiments, it really makes you wonder, right? What other waste out there is just hidden data? What other billion-dollar ghosts are just sitting in file drawers waiting for us to turn them into wisdom?